This is the R Podcast Screencast number 2, Visualization with ggplot2. Okay, so next I want to set up kind of the example that we're going to use in this demonstration of ggplot2. And the type of data I'm going to use, I'm actually going to something that I've been really wanting to do for a very long time. Now I'm going to be using actual data from the NHL, or the National Hockey League. Just a bit of, intro to this. I've always been a very big hockey fan for growing up, and I just think as a fan standpoint, the sport is really exciting because you have such great kind of continuous action, really intense moments, and there's such a great feeling to see like a goal scored by your favorite team. It just is so cool to see. So it's really always been one of my favorite sports to watch. And then on putting on my other hat, kind of my analysis hat or statistics hat, I think hockey in general might be actually one of the more challenging sports to really kind of analyze from a data analysis or a statistical point of view. Because unlike baseball, where baseball, that sport is, you can really think of it as a set of discrete type events, hockey is just more continuous in nature, and so many things can occur during the game itself that I actually kind of enjoy having a challenge of really looking at that data effectively and seeing what we can, make out of it. So with that said, the data that I'm using today comes from a website called the Hockey Summary Project. And this started, apparently the authors started this back in 2001, and it's one of the very few sites I have found that have actually put out some really easy to use hockey statistics. And I think it's really cool to see that. And, I've actually looked for hockey stats for a very long time. And finally, I kind of saw this from another blog about, sports statistics. And so I went ahead and signed up on their group, and they have a group on this Yahoo pages, and I'll put all the links to this in the show notes, where they make available all these different regular season and playoff statistics going back all the way to 1917. And most of the years are covered here. There's a bit of a gap, I believe, in the 30s and up to the 50s, but once you get past that, they basically have everything here. So I really want to thank these guys for putting such a great resource online for kind of a numbers guy like me to really take advantage of looking at these data in a easy to use format. So what I've done is I downloaded all of these files, and I basically imported them into a big data frame, and they have different types of data files. What I'm going to look at in today's episode is data about each game that's played in the regular season. And I'm going to be looking at, somewhat recent years, but this kind of brought to me, an opportunity to really show off kind of how we can use a visualization package like ggplot2 to really get up to speed with this and see kind of what ggplot2 can do. So if you're watching on the screencast, you'll see that I put up the R Studio interface that I'll be showing this plotting code with right now. And so I've actually utilized the project template package to kind of automate the data cleaning and data loading that I had to do to get the data ready for this. So what's nice is once I do that once, it all runs very quickly. And what I'll be doing is after this, I record all this, and I'll put all of the content, the code that you'll see in the screencast and I'm talking about via the audio in one of our GitHub repositories, so you can definitely take a look, after listening to this. So the first step in all of this is I wanted to get kind of the data subsetted to what I wanted to use for the visualization. And what I'm going to be interested in today is actually showing via ggplot2 and really kind of looking at the distributions of each game's kind of attendance numbers. And attendance here meaning like what were the number of tickets sold for each particular game. And I'm interested in kind of looking at the distribution of all these kind of side by side via the different teams in the NHL. And of course, we're going to be doing this with the ggplot2 package. And the only things I'm really doing from a subsetting standpoint is for the purposes of today, I'm only going to look at the years of 1994 and up to today, which is, of course, 2012. And one thing that the NHL has done recently is on New Year's Day, they've held for the past few years now kind of an outdoor game at one of the either a baseball stadium or a football stadium here in the U.S. And likewise, there's been a day in the year where two Canadian teams have played each other in one of the outdoor stadiums up in Canada as well. But what that does is, because those stadiums are so much larger, they're kind of what I would consider huge outliers that might influence what I get from my distribution analysis. So I'm actually going to subset the data such that I'm only getting those games that had an attendance number less than 30,000, which, obviously most of the NHL arenas won't even be close to that. So that's kind of a good way to, filter out those other, outdoor games just for the sake of today's tutorial here. So once I subset that, I'm going to call that object called plot.data, and I'm actually going to use appropriate enough the subset function, where all I'm feeding into it is my regular data frame for these games. I called it reg.game, and I simply have as another argument the subset parameter, and I have kind of a joint conditional of attendance being less than 30,000 and the year being greater than or equal to 1994. And so once I have that, now I have this data frame called plot.data, and that's going to be everything I need to get up to speed with this, start with this analysis. So I'm actually going to zoom in here on the screencast, so hopefully this will be more easily read than the last time we had this. So the first step in the way we use ggplot2 is to actually kind of initialize the plot itself. And so the way we do that is via, appropriate enough, the ggplot package. And what we do, or of course we load the package first via the library function, which is of course library, and then we feed in the argument ggplot2. That's easily done. And then now I'm going to create kind of an object that will initialize the plot itself. And the way I'm going to do this is with the ggplot function. And what you need to know about this function is just a couple basic things. I'm interested, of course, the first argument being what kind of data you're going to put in as a visualization. And you use appropriate enough the data argument. So here I'm going to say data equal plot.data. That's simple enough. And then the next argument, I mentioned earlier in the episode about these aesthetics that you use to tell ggplot kind of what you want to do with this data. So I'm going to go ahead and and initialize this via the AES function. And this is within the ggplot function, of course. And the AES function will have different arguments for what you exactly want to put in, as far as what do you want for your x variable, which will be, of course, on the bottom axis. And what do you want on your y? What do you want to be your variable on the y-axis? And then if you want to do things that differentiate, maybe use a variable to do different colors or different other aesthetic details, that would go in here too. But what I'm only going to do today is I'm going to first declare that my x variable is going to be within the data frame home.team. and then my y variable is going to be called attendance. So that's within this plot.data. I have in this the actual, home team, attendance, and a bunch of other things as well. And so then I can just close out with close parentheses. So what I have here is I'm going to assign this to an object called myPlot, just something easy to remember. So I've done myPlot in the assignment operator, ggplot, and then the first argument, data equal plot.data, and then AES, x equal home.team, and y equal attendance, and then just simply close all that out. And then I'm just going to run that. And then what you'll see is now in my lower pane here, I have an object in this values part of RStudio. I have an object called myPlot. And you'll see the type of that is actually a ggplot object. And so you might be wondering, why did I need to assign it to an object right now? Well, what happens is that in ggplot, just using the ggplot function on its own is actually not the full story to get the plot actually visualized. What you need to, and I'll show you what happens, and I'll describe it on the audio, but if I just wanted to see this object, myPlot, and run it, I get an error towards the bottom that says in the console saying there are no layers in the plot. So this is getting back to that concept I was talking about previously, is that ggplot, in order to see things, you need to put layers on top of your initialization of the plot itself. So this myPlot object is simply just initialization of, you can think of it as like the canvas of a painting without anything on it yet. This is what we're going to put it on, and we're going to use all these layers to do just that. So one thing, if you're curious about, is you can use another function called summary, and you can actually use summary on a lot of different things in R. And you can simply see what this myPlot object is really representing in terms of ggplot2. So all I did, of course, is I used the summary function, and the argument is simply myPlot, which is what I used as the object. And in the console, what you'll see after executing that is we have a set of kind of values that are summarized here, first of which is data. And what you see there is actually all the column names of that data frame that I fed into that earlier ggplot function. In this case, you see about 21 columns here, and about, according to the data at the end there, 18,000 rows, just a little over that. And then you'll see another section called mapping, where it has x equal home.team and y equal attendance. So that was what I used in that AES function within the ggplot call, because that is simply the default aesthetics that I'll be using that all of the future layers will build off of. And then that last line that you'll see is called faceting, and it says facet underscore null. And all that means is that I haven't done anything to split the plot up into different areas. You could think of it as like different parts of a grid. And there will be a function that I talk about later on that will kind of, separate the plot into different parts on the actual visual. And that's usually called facets. But anyway, this object called myPlot is now this, in essence, this blank canvas. And the only thing it knows is the data where we want to plot, and also the aesthetics of the x and the y variables that will be used in the plot itself. So that's just kind of something nice to kind of see under the hood of what ggplot's actually doing. So that's all well and good, but now let's start adding layers to it. So what we want to do is, the way ggplot does these layers is you basically add things on top of that initial ggplot call, or in this case, I've assigned that to an object called myPlot. So all you really need to do to start this is you just do your object name and then a plus sign, and what comes after this will be the layers that I add on top of this canvas, if you will. So the type of visualization I'm going to be interested in today is side-by-side box plots. And box plots are pretty useful just to get a sense of the distribution of your variable of interest. And I want to compare this from team to team. So in ggplot2, I now have at my disposal all these different geometric objects or functions that we can use to develop this layer. And appropriate enough, the way we do this box plot layer is using the function called geom_boxplot. And so let's talk about, after we put that function in, what are the arguments that we're going to need here. So by default, each of these layers will, these geoms, which again are these kind of layers, you'll need aesthetics if you want to do anything in addition to the aesthetics that you've already specified in your original ggplot call. Here, I want to do one additional aesthetic that I didn't put on top because I want to color these box plots by what conference, either the Eastern Conference or the Western Conference, that these teams are coming from. So all I need to do there is, much like the ggplot function above, I have put in my ggplot, or that geom boxplot call, the AES function. And because I said I want these box plots to be filled by different colors based on conference, this aesthetic I'm interested in is called fill. So within the FILL. So within this AES call, I'm going to say AES parenthesis fill equal, and then now the variable that distinguishes what conference these teams are coming from, and I've already created that in the original data frame. It's going to be called home.conference. So this is saying to ggplot2 that, okay, my first layer is going to draw box plots with the x-axis being what I specified above, the home team, the y-axis being the attendance, but now filling the color of those based on another variable called home.conference. So once I have that in, then I can put in additional parameters that can kind of customize the way that the geom boxplot layer is working. And one of those parameters is called width. And because I'm going to be having multiple teams represented here, I don't want the box plots to be so wide that they're really kind of scrunched on top of each other. So I'm going to use the width parameter equal 0.3. And that's just the kind of unit scale that ggplot uses. Well, you'll see that'll be a pretty good value to use here. And then the other thing I want to tell this function is I don't really want to see the outliers on here because that might clutter the graph a little bit. So they have another argument called outlier.color, and for this you have to be a little careful. They actually use kind of the British spelling of things like color, although in some functions you can get away with kind of the more typical spelling of COLOR. But in this case, I looked up in the documentation, this argument's called outlier.color with the British spelling. But to say that I don't want these outliers to be colored, I'm going to assign the color in this argument to be NA, which in R is kind of the default way of saying set something as missing. So that's really all the arguments I'm interested in from the geom boxplot function. So with that, I've closed up the geom boxplot call, and then when I run this, what you're going to see is actually a first shot at this ggplot2 boxplot. So here on the upper right quadrant in RStudio, you'll see that I have now side-by-side box plots of all the teams on the x-axis and the attendance. And if you look into this graph closely, what you'll notice is that the home team, the x-axis, because all these team names are kind of long, where they say like the city and then their kind of nickname, everything's kind of on top of each other, which makes it really hard to read which team is what. But on the y-axis, the attendance axis, you'll see it goes from, it uses kind of intelligent defaults for the ranges of values. So it started from 0 all the way to a little over 25,000, which isn't too bad. And then on the right part of the plot, you'll see kind of a little legend that's already been populated. The title of the legend is called Home.Conference, and it has now the Eastern Conference teams assigned a reddish color, and then the Western Conference teams assigned a bluish color. So the nice thing about ggplot2 is that it will make these legends for you automatically, which, for someone like me, saves a lot of work versus the traditional plot function in R, where you have to kind of code the legends yourself in a little bit. And to me, it sometimes isn't so trivial, although I've obviously seen some really good examples of it. But for me, the ggplot2 way of doing it makes it slightly easier. So, like I said, now we have a plot that we could actually visualize, and it showed up in our graphical window. But we have some things we want to clean up on this and tweak a bit. So I'm doing this kind of in an interactive fashion. And to be honest, I think Hadley, when he wrote ggplot2, he expected most users to use, ggplot2 as kind of in an interactive way of exploring your data and kind of building these visualizations kind of layer by layer in somewhat of an interactive fashion. Although what you'll see later on is we can wrap this all up in some nice kind of reproducible code once we get a visual we're really happy with. So my next step, I'm going to do some different customizations to this current plot so that I would be happy with it if I was going to say put this in some kind of publication or even just post it online somewhere. The first thing I want to do is I would like to narrow the range of the y-axis a little bit. I would kind of like to constrain it a little bit because it's very rare that you have games in which there are less than, say, 10,000 fans in attendance, although I've seen it happen before, but I'm more interested in the range of, say, 10,000 up to, let's call it 23,000. So when we do ggplot2 in this interactive fashion, there's a really nice kind of function it gives you by default, and they call it last underscore plot, because ggplot will save whatever your last actual visualization was into memory. And you can actually use this in an interactive fashion to kind of build things up from what you previously plotted. So in this case, I'm going to type last underscore plot and then just do an empty arguments inside it. So open close parenthesis. And then I'm going to now put in another customization, much like how I did the first layer in the previous line of code. So I'm going to put in the plus sign again. And the way you can kind of, in essence, zoom in on a plot via specification of like a range of axis, numbers, you use a function called chord underscore Cartesian. And this is actually very important to know if you want to zoom in on anything, because there are a couple different ways I could accomplish this, but the chord underscore Cartesian function will ensure that I haven't chopped off any data points that are outside of the range that I'm specifying here. And because I'm saying that because you could also use another function called like scale underscore x or y underscore continuous, and you could put in your limits of the axis you're interested in within that particular function. But don't do that if you just want to zoom in on a plot, because that will actually eliminate any other data points you have that are above or below the range you specify, which will obviously influence any calculations in the statistical functions that ggplot2 uses for whatever geom you're visualizing. So in this case, like I said, I'm going to use the chord underscore Cartesian function. I'm going to feed in just one argument actually, called ylim, so YLIM, and then I'm going to say that's equal to a simple numeric vector with two numbers. In this case, the first number is the lower part of the range, so I want 10,000, and then comma, I'm going to feed in the highest part, which is 23,000. Then I just close that call up, and then now I'm going to run this specific line, much like how I did before. And then what you'll notice then is in the plot itself, I'm going to zoom into it here, you'll see that now the attendance is now narrowed on the y-axis from 10,000 to has a tick at 22,000, but the top of that graph would be, right at 23,000. So now I'm starting to see a zoom in view via the y-axis on the attendance figures. So that looks like I'm getting, closer to what I want. And so I got a couple more customizations left that I want to do to get this kind of ready to be, really assessed visually. The next customization I want to do is, by default, ggplot2 will use kind of as a background this light gray with white lines kind of dividing, in essence, the ticks of the x and y axis on the background itself. And most of the time that's fine. But for me, I'm kind of used to having more of a white background with like a darker line for all these kind of axis breaks, if you will. But the nice thing is once again, there's a very simple function to just get that kind of whitish background, and that function is going to be called theme_bw. And so in order to do this on top of what I've already done, once again, I'm going to call that function called last_plot, which will have everything I've done up to this point in memory. And then I'm going to do a plus sign and then do the function theme_bw, again with no arguments, just an open close parenthesis. And what that will do is when I run that, the plot background has now changed. Now, instead of having the gray background with white lines, behind, it now has a white background with grayer lines to denote where those axis points are. So this is obviously more of a visual thing for me personally, but it's nice to know that ggplot gives you that functionality to kind of switch between those two built-in themes. The default theme is that, I think they call it a theme grayscale or something similar to that. But I tend to like the theme BW just because if I wanted to show this off to other people, I think it's just a little more visually pleasing. But like I said, it's kind of a subjective thing, depending on what you really like in your plots. So now I've got that customization out of the way. I got a couple more to go. The first of which is now you notice that my labels on the X and Y axis say home.team and attendance respectively, which may be fine for general purpose. But I'd like to give those labels a little more verbose, kind of a little more maybe cleaner kind of font, or I should say text. So as of ggplot2 version 0.9, or maybe it was in there before, I don't recall, but there's a nice function that we can use to just control the labels of these different aesthetics called the labs function. So let's talk about how we do that. First of which is we're going to simply, once again, call the last_plot function to get where we left off, and I'm going to add now, via the plus sign, another function called labs. And this one I am going to put some arguments with because they're going to correspond to the different aesthetics I put on this plot itself. So the first aesthetic is going to be appropriate enough X, and I'm going to call that, instead of saying home.team, I'm just going to call it team. And I'm going to call it with a capital T just to make it a little cleaner. And for the y-axis, I'll actually use the same word, but I'm just going to capitalize it. So I'm going to say y equal, and then attendance with a capital A. Now that covers the X and Y, but we can also control what the legend will use via its labeling as well. And to do that, I'm going to use the aesthetic called fill FILL, because that's what I put in that box plot call, the geom underscore box plot function, for the aesthetic for coloring based on conference. Now, by default, it gave a label the same as the variable name, which was home.conference. Here, I'm just going to say fill equal and then conference. And that should take care of the way the legend is labeled in the actual legend part of the plot. So let's go ahead and run this. And then what you'll see then is after you've done this, now the plot itself has different labels on the X, the Y, and the legend part of the plot. They're exactly as I specified in the labs function. So now we're really close now, but if you notice, I've been saving something for last, and that's cleaning up all these team names that you see on the x-axis where they're all kind of scrunched together. Obviously, I can't read anything about that. So the way I'm going to do that is I'm going to use, I believe, a relatively newer function in ggplot2 that will take care of all these details via these options, and that function is called OPTS. And like I said, maybe this was in there before, but I've only learned recently how you can really use this to get to what I'm looking for. So I'm gonna in essence cheat a little bit here, because I'm just going to copy all that from another file and then put that into this R script that I'm showing right now. But let me verbally describe what I've done here. I've again used the let's see, that's the wrong button. Let me go here. Okay, so I've used the last.plot function again like before, and now I've used the function called OPTS. This is ggplot2's global function for controlling all these different options within the plot itself. So first, I'll tell you what all these are, but then I'd invite you to look at the code file if you want a lot more details. But I'm going to specify within this ops function the title of the plot, which will appear at the very top. I'm going to call that distributions of game attendance. So that was with the title argument. Next, there's another argument called plot.title, which may be a little redundant if you think, I've already done the title, why do I need this? Well, these versions of these title type options will let you control things like how big the font is, the style of the font, the orientation, etc. And to do that, you assign as an argument to this plot.title object a function called theme_text. And within that theme_text function, you can control a lot of different things. In this case, I'm going to say size equal 20. So now I just said, okay, make that title I just specified for the plot font with size 20. So next, I have a couple arguments to denote things about the position of and also aesthetics about the legend itself. Now, by default, the legends always appear kind of on the right side of your plot, kind of in a separate pane, if you will. But you can also tweak where you put that, and you do that via an argument called legend.position. And in this case, I'm going to say I want that at the very top, right under the title. So all you feed in as the value for that is a character string saying top. I could have done like bottom, left, right, all, and even within the plot itself via different coordinates. But for today, I'm just going to put it at the top. Next, I have an argument for legend.title. This will be just like that plot.title argument, but now I'm going to use, once again, the theme_text function as its value. And within that, give it another argument for size. I'm going to say that equal to 20 as well. So that was the title of the legend. Now within the legend itself, you saw it broke up, it had text for like east and west. And I'm going to give that size a little boost too via the legend.text argument. And again, what I'm assigning to that is the theme_text function. And I'm going to give that font an argument of size equal 12. So a little smaller, but it should be more readable. Now the most important parts that I'm doing this are for the axes themselves, where I want the team labels, instead of being all kind of on top of each other in a horizontal way, I want to make it so each team label is on a vertical orientation so that we can easily distinguish what team is what. And we can do that with the axis.text.x argument. This is all within that OPTS function. And I'm going to say that, again, equal to theme underscore text, parenthesis. Now I'm going to give an argument called angle equal 90, i.e. to flip those labels 90 degrees. So that will help a lot. And I'm going to give it a boost in the size and say size equal 12. So basically, everything else in this OPTS call that I have follows a similar way. And I'm just customizing certain things about the aesthetics themselves. And so once I'm finished with that, and then I go ahead and run all this, and again, it's the last underscore plot, and then plus this OPTS, and then all these different arguments inside. Once I do that, then you're going to notice that the plot looks a heck of a lot better now. And so I'm going to zoom in on it and describe to you what we've done here. What we've done here is, what you'll notice is now the team, the x-axis, all the teams are the names are vertically oriented, and they're a bigger font. So we can clearly see that the left one is the Anaheim Ducks, and the very right is the Winnipeg Jets. And so now I've also done some customizations to the font size of the title, as well as the title itself, distributions of game attendance, and then you'll see under the title I have conference and then those colors for east and west. So now the legend went from the very right to now right under the title of the graph. So that to me gives me a little more real estate, if you will, of the plot area. And so now this is at the point where I can actually start looking at this and discern what is what here. And so a couple trends that I'll describe to all of you that I noticed kind of right off the bat. One thing I've noticed is that obviously there's a lot of variation from team to team. But I think to tell the full story, and what I'm really interested in is I want to see how the attendance figures compare between the years that I've collected before the NHL lockout occurred in 2004, where basically the whole league shut down for a year because there was a dispute between the players and the owners on various issues, and the attendance figures after the lockout ended, which was a full year later. I think that would be quite interesting to visualize. So I'm going to go ahead and close then the zoomed of this, and I'm going to add onto this last plot again a new function that I think is really powerful here to do this kind of layering, if you will. And that function is going to be called facet underscore grid. So I'm doing, again, last underscore plot, because it'll have everything I've done up to this point. And then plus, now I'm going to call facet underscore grid. And what this is going to do is that it's going to partition the graph into two different, or actually multiple areas, depending on another variable. So in this case, the way you do this is via what they call kind of a formula interface, where in this case, I have a variable called era.ind, which basically gives for each game whether it occurred before the lockout or afterwards. And then, so that's my first stuff that I've typed in here. Now I'm going to type a tilde sign. And if I wanted to do another variable to split them up even more, I would put that to the right of the tilde. But in this case, I don't need to do that. I'm just interested in what's the difference between these two different eras that I've called it. So to do that, you just put in to the right of the tilde a period, which means just use the rest of the data as it is. And so there's only one other argument that I'm interested in here. So after I've done this formula specification, I'm doing a comma with margins equal false. The reason I'm doing this is that I don't need to see the both eras put back together as a separate facet in all this. I'm just interested in the two facets of before the lockout and afterwards. So once I type all this in and then I run this, and of course, if you're watching on the screen, I mistyped facet. I did face underscore grid, which could be a really wild function. But anyway, it's supposed to be facet underscore grid. So I run that. This should hopefully get me what I'm looking for. And it does, actually. So I'm going to zoom into the plot and describe to you what I'm seeing. What I'm seeing now is I have, on the very right, now I have two partitions, basically horizontal partitions of these box plots. The upper quadrant has on the right some text that say post-lockout. So this is the attendance distributions for all the games that occurred after 2004, i.e. after the lockout. The bottom partition, the lower half, is pre-lockout. So this will be all the years from 1994 to up to 2004 that I subsetted, in my earlier call to get the plot data. This is what I was most interested in, because I want to see when you go from the different times in the history, the recent history, I should say, what's the difference along all these attendance figures? A couple of things immediately jump out. You'll notice for some teams, the box plots are almost like little horizontal ticks even on this plot itself. You know what that means is that all the tickets sold for that team were basically what we call sellouts, i.e. all the tickets were sold. And full disclosure, my favorite team on this is the Detroit Red Wings. And you'll see that both the pre-lockout and the post-lockout, compared to the rest of the box plots, it's really just this little horizontal tick, i.e. there's very little variability in the attendance figures, maybe slightly more in the pre-lockout, but not by much, where it's right around 20,000. So I know from growing up, especially before the lockout, they would always sell out. Now, I'll go off on a little tangent here. I've said tickets sold, and I know from what I've seen that after the lockout, because of the economy in the United States, especially in Michigan, that the Red Wings would have trouble selling out some of the games in the regular season in recent years. So I may want to look into this a little more carefully, because I don't think I'm getting the full representation of this via the attendance numbers. But anyway, enough of that tangent. The other parts I noticed is that some teams had quite a boost in attendance after the lockout ended compared to before. A team I'm looking at right now is actually the Carolina Hurricanes, where their box plot showed a lot of variability or spread, anywhere from a little lower than 10,000 to a little under 16. And then that's before pre-lockout. And then after the lockout, the distribution via the box plot really kind of tightened up, much more so, anywhere between about a little less than 15,000 to a little over 18,000. And that makes a little more sense also because I believe they won a championship after the lockout as well. So, and then there are other teams that also had this kind of big boost after the lockout as opposed to before. One of them is the Buffalo Sabres, located in Buffalo, New York, who had a lot of variability in their attendance, before the lockout occurred. And then afterwards, they have really sold out very well, where now it's just that very tiny box plot, right around, say, a little over 18,000. So they definitely have come a long way. And you can see similar trends, sometimes even the opposite way for some teams as well. But it was just interesting now that I have actual hockey data to really analyze and visually see this. And I've done it all in ggplot2 with a relatively small amount of coding. And to me, it's appeared quite logical. So you've seen that in an interactive fashion, we have now gotten a really nice publication quality plot. Now, I've pretty much settled on the way I constructed it. What if I want to kind of reproduce this later on? Well, what you can do, it's a nice little trick, is that in ggplot, you can actually make objects out of these actual layers that I put on top of the kind of the base plot itself. And so what you'll see, and then when you access the code after this podcast on the show notes is, let me first zoom out there. I'm going to actually copy in, if you're watching on the screencast, some really interesting set of code that actually does what I've just described. So what I've done is I've now made objects out of various kind of layers that I put as I kept calling like last underscore plot plus and stuff. And those different layers I put after the plus sign, I'm making those now little objects. So I have like myplot.labs, I've assigned that object that labs call that I did that defined the label text. I've also done one called myplot.theme, which is taking a list of all those different kind of theming components that I had, versus whether it was the theme BW call or all those options that I did for like the font size, the orientation, etc. I've also done a layer or object called myplot.zoom, which contained that chord underscore Cartesian call that would zoom in on the y-axis. And lastly, I did a myplot.box object, which had the layer for actually getting the box plot on in the first place. So that was very straightforward. I just assigned all those different objects. So what the nice thing you can do with all this is you can now use those layers that you've created as objects in very simplified calls into ggplot2 to create your graph. So I'm going to start with a clean slate. I'm going to clear the graphs that I've done up to this point, and I'm going to copy in some more code that actually does this, just for the sake of ease of time here. I'm going to start off like I did before, where I kind of what I call put the canvas up, where I assigned an object called myplot, the ggplot call with the data and the two aesthetics for x and y that I'm going to start with. So that's just like before. I'm running that. But now what I can do is now I can add on top of myplot all these different objects I've done for those different options, or I should say those different layers. And I'm doing it in the same order that I kind of built things off of. But then and it's really simply myplot plus, and now myplot.box plus myplot.zoom plus myplot.labs. And it's all in one line, etc. And then when I run that, I'm actually, and again, once again, I mistyped something here. Could not find my plot. Oh, I know what I did. I didn't execute all these objects being saved. Let me do that real quick, and then run this. That's the beauty of doing this live. Sometimes you forget to do certain steps. Okay, so once I do this, and then I run now that line where I kind of called everything on top of my plot, you'll see now I have that same exact plot that I did. Apparently I forgot to do the label of the x-axis, but that's okay. In fact, now I see the problem. I think I've run the wrong thing here. But yeah, I see what happened. I did the wrong label for the y-axis in my call to all this, so I'm going to fix that on the fly here. Forgive me, folks. That wasn't supposed to be done here. So I'm going to kind of recreate what I did before, where I called x equal quote team in the labs function. Sorry about that, guys. And then I'm going to rerun all these objects again, and I'm going to get what I intended to get right off the bat. Must have been a copy paste issue. Yeah, that's what I'm looking for. Okay. So all I did again is I saved all those layers as different objects in R. And then when I built that plot via the ggplot2 call, and I saved that to a myplot object, I just simply added all those layer objects on top of my plot, and I got the same graph that I got before. And so that, in a nutshell, is how you can reproduce things in ggplot2, so that now that you've found the type of visual you want, you can go ahead and save these different layers, or even, like I did before, I saved kind of what I call the base call of it. And you can really tweak certain things and only have to tweak it in one place. And you could change this up. You could do something different for the y-axis. It would only need a couple different tweaks, and then you could run basically the same code. So I really like the flexibility that ggplot2 offers when it comes to visualization. So we spent quite a bit of time going through this example, and I must say I've only scratched the surface of what ggplot can do. I've done these kind of side-by-side box plots, faceted by another variable and then colored by another. But there are so many other visualizations you can do. And I wouldn't be surprised that in future episodes we do kind of a more advanced look at ggplot2 as well. So I'm going to close out this episode with some really great resources that I found for learning ggplot2 and understanding how it works. I think the best way to learn is to learn via example, and that's why I went through this example in great detail to hopefully show all of you the great capabilities of what ggplot2 can do. So the first resource I want to mention is actually something that we had some listener feedback about from Charles back about an episode or two ago. And there's a nice website by Winston Chang called the R Cookbook. And this is really nice because on top of some of the basics about R that Winston talks about, he has excellent sections on ggplot2. So like I said, I'll have all these links in the show notes, but I would highly suggest looking at all of his examples for graphs with ggplot2 because he does it in a very nice, easy to understand way. To be honest, probably even easier to understand what I just did. But it's really nice to have as a reference if you want to do more with and kind of get started with ggplot2. And there's one type in particular that I use to this day is the plotting means and error bars tutorial that he has. It's a really nice application of summarizing your data via summary statistics and then putting that into ggplot2. It is an excellent tutorial and I highly recommend this site. The other site actually is appropriate enough, the home site for the ggplot package, or actually ggplot2, and that's been constructed by Hadley Wickham himself. It's the link is had.co.nz/ggplot2. And what's nice about this is it's kind of like a visual help page and example database for what ggplot2 can do. And I believe this has been built for quite a while, and I don't believe it's been updated since the recent update to ggplot, but it has some excellent examples of the basics and all these different geomes or geometric objects that I talked about. And for example, of course, he has one for box plots. So if you're wanting to do more box plots on top of what I've showed you, I would check this out as well. And then you'll see, once you click on these links, you'll see that in the example section, he visually produces all these different calls to ggplot, and there's a lot of cool things you can get just from browsing this particular site. So that's another one you'll definitely want to put in your bookmarks. Some others before I close up shop here. On GitHub, Hadley has produced the ggplot2 wiki page, where it has some really cool, kind of verbal, or I should say more verbose descriptions on, ggplot2 around the web, some FAQs, and some good examples. He calls them case studies from, I believe, dating to 2010, where they have used ggplot2 in a real application, whether it was, a report or a post online or, whatever have you. He's done some really cool summaries here, so I would check that out if you're interested as well. As far as getting help with ggplot2, there's of course one way you could do it is you could search on the site called stackoverflow.com, which I mentioned is kind of like the nice Q&A forum for all things about R when you put the tag R in your query. Well, on top of that, there is the actual ggplot2 group on Google Groups, so it's basically a mailing list where it has a bunch of questions about ggplot2 that are answered by a lot of users out there who are definitely more of an expert than I am in this package. But there's some really good stuff here. If you have a question, I would suggest looking at this group and at least searching there. And, if you're more interested in even joining the group, so that if you have an answer to offer to somebody, I would go ahead and sign up on that and see what you can do. So that covers kind of a mailing list type setup for ggplot2. There's another site that I just heard about recently. It's actually, I would consider, an aggregator blog for a lot of ggplot content online. It's called blog.ggplot2.org. And I literally learned about this about a week ago. And it has some really good posts that the contributing authors have found that mention ggplot2 or demonstrate ggplot2 in some way. So I just, subscribed to this via my Google Reader, and I've already found some really cool content on here with examples and other tutorials about ggplot2 that I wish I had even a while back. There's some really good stuff here. Lastly, just a few more sites I'll mention. There's been a blog called Learning R, and what the author of this blog has done is he's actually replicated a bunch of graphs that were in a textbook called Lattice, Multivariate Data Visualization with R. And he's done a series of posts of basically replicating all those plots that were done via the Lattice package, and he's done them with ggplot2. I actually learned about this quite a while ago, and I thought it was just fascinating to see all these different examples of plots with ggplot2, and it gave me a lot of good ideas to pursue further. And I think he's done an excellent job of course, putting the code from both the Lattice version of a graph and also the ggplot2 version of a graph. And he puts them, basically side by side, the actual plots themselves, and you can see the differences and compare and contrast between these two powerful visualization packages. So I would definitely recommend checking that out as well. Two others before I sign off here. First of which, there's a great application of ggplot2 to produce what are called Kaplan-Meier survival curves, which those of you who have had statistics and know about something called time to event analysis or called survival analysis. This blog called Matt's Stats and Stuff, he's done a really nice example of visualizing a Kaplan-Meier survival plot and then putting on the bottom frequencies on how many, like in this case, like patients or subjects that are at risk in each of these time points. And I just was really interested in this because I had never seen this done in ggplot2 before I got wind of this blog. And he's really done a nice job of creating a function that does everything that you would want in this analysis. So it just kind of is a nice illustration of what you can do with ggplot2 to customize it to your actual analysis needs. And I've actually used it in some actual projects, and I got a really nice visual out of it. And I could, still stay in my comfort zone of using ggplot2 instead of having to go back to another part of the visualization techniques in R. I could do it all within this. So I just thought it was a really interesting, example of extending ggplot2. The last one before I close up here is one that I got from that kind of ggplot2 aggregator blog, and I think the name is in French. I'll probably butcher it, but it's like CodeALaMode, and I'll have a link to it in the show notes. But the author of this, he has done a series of posts about using ggplot2 via specific examples and even also a nice tutorial as well. So I just bookmarked this when I discovered it because, I think once again, the best way to learn is through example. And he's got some really nice examples here that I think are actually a nice companion to the R cookbook and, of course, the ggplot website as well. So I've talked about all of these because I think all of these are really instrumental and helpful in learning about ggplot2. And actually, I almost forgot one thing as well, is that when ggplot2 was upgraded to 0.9, there was a nice document that was produced by the development team to talk about all the changes and additions to ggplot 2.9 as opposed to what was in the previous version. And on top of the technical details, it has some really cool examples of some of the newer functionality that ggplot2 is offering as opposed to the earlier versions of the package. And I've used this extensively because there's some really cool, geomes that they've, constructed now. One's called like geom_violin, where it's kind of showing a different way of viewing the distribution of data. And I started to play with this recently in some projects, and I think I really like what it's doing. So I'll have a link to this PDF in the show notes. And so if you have experience with ggplot2 and you wonder what's new with the new package version, I would check this out because it really gives a nice breakdown of what's new and what's changed. So on top of that, I'll close by saying that if you're really interested in more of the theory behind ggplot2, I would recommend, purchasing the book by Hadley Wickham, and it's called ggplot2, Elegant Graphics for Data Analysis. And I'm actually going to search for it on the screencast here because I forgot to open the link on my browser here. So I'm just going to show you quickly what it looks like. You can find on all the retailers like Amazon, etc. But I bought this about a couple years ago, and it really was nice just to kind of see behind the scenes how ggplot2 works on a kind of a theoretical level. But I would say, to really appreciate the material here, I think it's helpful to even start with some of these online tutorials first, because that will kind of introduce these concepts. And then what Hadley's done is he's really put a lot more details and what is the motivation behind certain things and how you can really customize ggplot2 even more than what's offered by default. But I think to become a true master with ggplot2, I think it's worthwhile to get the textbook as well. But, depending on how far you want to go with it, like I said, I would highly recommend it just because for me, I'm kind of sticking with ggplot2 for most of my visuals now. So I would still recommend that to textbook if you really want to take it to a next level, if you're doing this on a routine basis and you really want some powerful visualization. So yeah, I think that this seemed like a very long tutorial. I think we're going to wrap this up now. But I've really enjoyed kind of showing off ggplot2, and I hope you see just how powerful the package is. So I'll close with, of course, talking about where you can get some more information. Of course, all the show notes for today and the past episodes will be on our home site of www.r-podcast.org. And of course, you'll see the RSS feeds for the audio podcast as well as the upcoming screencasts that I've recorded as well. We also, as I mentioned, we have the brand new R Podcast forums, and you can find those at r-podcast.org/forums. We also are on Google+, and I have a link directly on the home site, and that the short link to that is goplus.us/R Podcast. Lastly, we will have show updates announced on our Twitter account, and that's at the Rcast. So, with that, I think we're ready to wrap this episode up. Thanks a lot for listening, everybody. And until next time...
End of line.